everyone, today I'm going to show you some common topics for chemistry. The first one I would like to show you today is the half-life of first and second order reactions. How to calculate the half-life of a reaction. First, we need to know to understand what is half-life. The half-life of a reaction is the time it takes for the reactant concentration to decrease by half from m to m divided by 2. After one half-life, the concentration falls from the initial concentration m0 to m0 divided by 2. After a second half-life, it will decrease to m0 divided by 4. After a third half-life, it will be decreased to m0 divided by 8 and so on. For a first-order reaction, the half-life is consistent. It depends only on the rate constant K, and for the first-order reaction, the rate constant K has a unit of second minus 1. And this equation shows the half-life for the first-order reaction. 0.693 divided by K. Second-order reaction. The half-life depends on the rate constant K and the concentration of the reactant. In this case, the rate constant K has a unit of m-1 times second minus 1. And the equation is shown below. Now next we will go to some practices for the half-life. First, questions. A certain first-order reaction has a rate constant of 9.3 times 10⁻³ seconds minus 1 at 45 Celsius degree. How many minutes does it take for the concentration of the reactant to drop to 6.25% of the original concentration? So now we will go to the solution. Step 1. We need to calculate the half-life of this reaction. Because this is the first order reaction, we can apply this equation to calculate the half-life of this reaction by using the number of 6.93 as a constant, and we already have the rate constant K was given before. And applying this equation, we can calculate the half-life of this reaction is 74.5 seconds. This is the time it takes for the reactant concentration to decrease by half. Step 2. According to the question, the concentration of the reactant dropped to 6.25%. 0.25% of initial concentration of X equal to 1 to 16 initial concentration of X. And we use this equation to express the reduction of concentration of reaction X regarding to the half-life cycle. Starting from the initial concentration X0, from one half-life, the concentration reduced by half, and for a second half-life, concentration reduced by 1/4, and for a third half-life, concentration reduced by 1/8, and to a fourth half-life, the concentration reduced by 1/16 of the initial concentration X0. And using that, we know that the concentration of reactant X drops to 6.25% of the original concentration. So we will use the half-life of the X, which is 74.5 seconds, and times by 8. So we can have the minutes it takes for the concentration of reactant X to drop to 6.25% of the original concentration. So time 8 times 74.5 is equal to 596 seconds, roughly around 9.94 minutes. We will go to the second practices. The question second practice is: a certain first-order reaction has a rate constant of 1.55 times 10 minus 3 as 27 degrees and an initial half-life of 248 seconds. What is the concentration of the reactant Y after one half-life? On the first step, we need to calculate the initial concentration Y0 of this reaction. Because this is a second-order reaction, we can follow this equation. So the half-life of this reaction was given as 248 seconds. Applying this equation, we can calculate the initial concentration Y0 of this reaction. So applying this number, we can calculate the initial concentration is 2.6 molar. Step 2, we have to calculate the concentration of Y after one half-life. After one half-life, the concentration of reactant Y reduces by half. It means we use the initial concentration Y0 divided by 2, 2.6 divided by 2, so we can have the concentration after one half-life, which is 1.3 molar. And thanks for watching this video. Please subscribe to my channel to get more chemistry practice questions. Thank you.